Okay, so where and when and what are the benefits and costs of using these different methods in different circumstances? So land-based surveys are typically going to be seismic surveys. And this means that they can only cover a small area, which and they're quite difficult and potentially dangerous. And because it's a small area and you've got people involved, it can be quite expensive if you want to cover a large area. And it's going to take a long time to cover that large area, but it might be quite precise and accurate, depending on who's doing it and what sort of standards they're doing to. But this means it's really useful to provide a reference point to ensure that other more remote sensing techniques, things like from aeroplanes or satellites, are accurate. So they still have a place and they're still quite useful to do. Aeroplane-based surveys are going to be things like radar. Let's change the pen color. Radar. So that sort of ice penetrating microwave radar, radar altimeters, things like that, and also things like LiDAR or laser altimeters as well. These are going to cover a wider area much faster than a ground-based survey. It's closer to the ground, which will increase the resolution of our results, but then it also means it covers a smaller area than a satellite, which are obviously much higher. Okay. And then satellite surveys are what we consider really good and positive things now because they are so ubiquitous, but they're relatively new technology. These will use things like radar. They can use infrared lasers. And they are really useful for this gravimetry methodologies as well. There are two different types of satellite surveys. You have low Earth orbits, which is LEO. This is up to 800 kilometers in altitude. They take about an hour and a half to complete one orbit, which is one rotation of the planet. And this means that they can cover the Earth in 15 days to cover entire surface. There is one other type of satellite orbit that you might come across, which is geostationary, which is where it's in a fixed location. So it stays in one place in its orbit and doesn't change. And things like GPS receivers, they use this sort of orbit. And you also get geosynchronous. And this is where it will track one place on the surface. And this is used widely for things like weather satellites. And these two are typically found a lot further out, so they have a much higher altitude. So what is the benefit of a satellite? Well, there's quite a few. You've got things like they cover a really large area. Let's change color. Let's do it green. They cover a large area in less time. So 15 days to cover the entire planet. They can access inaccessible areas. Really important thing like Antarctica. It's technically safer because we're not sending people out to these places to go look for stuff. It's less labor intensive. And it can provide us with large amounts of continuous data. And this is all seasons. Depending on what sensor you are using, something like radar will not be affected by clouds, which means that you can use it at night time, you can use it when it's snowy or overcast. It can be done at any time. It's above the weather, so it's not like an aeroplane where it's going to get jostled around, or it might be too dangerous to take off or land, or it gets iced up when it's flying around. It's above and beyond all of that stuff, and it can reach out and see things using specific sensors. Gravimetry also is not affected by the weather, doesn't need clear skies, so it's really useful in that case. It's good to have some examples. So we have ISAT, which was a appropriately named satellite that used LiDAR. For surveying the altitude or height of ice and how it changed with seasons. When this failed or stopped working, it was actually replaced by an airplane under something called Operation Icebridge. You can tell these were named by Americans because they really go in for their amazingly descriptive names. So Operation Icebridge was an aeroplane that fulfilled, covered a gap in satellites. So while they're preparing the second ISAT, they used an aircraft instead. So ISAT 2 then replaced it using things like LiDAR again to continue the coverage as well. The second example is something called GRACE, which is a German-American satellite. And this stands for Gravity Recovery and Climate Experiment. And this is really interesting because it's a gravimetric system. And what you had was say this is our ice sheet where it thins in the middle. You have our GRACE satellites, which were actually two satellites, one after the other. And between the two was a laser beam measuring the distance. As these satellites orbited, when they went over thicker ice, the gravity would cause one of the satellites to speed up very, very slightly compared to the following satellite. So the distance would increase and can be measured by this laser. And then the second satellite would speed up and catch up and return them to their normal distances. And then it would do it again when it went over another thick bit of ice. As gravity increased, the first one would accelerate first, followed by the second one. And this change in distance caused by change in gravity is what was used to establish the amount of ice underneath it and how it changed, because this could cover the entire planet very quickly. So a really useful method to establish the amount of ice underneath it.